Hi everyone, I am Dr. A. Murugesan in Department of Biomedical Engineering from KSR College of Engineering. In this video, we discuss how to sketch the Bode plot in control system. So it's mainly used for frequency response analysis. To sketch the Bode plot for the given open loop transfer function, g of s equal to 5 into 1 plus 2s divided by s into 1 plus 4s plus 1 plus 0.25s. Before solving Bode plot, make sure all the terms are in 1 plus form, 1 plus s format. Otherwise, you change the format as 1 plus s format. So all the values should be in 1 plus s format. Make sure, then you have to proceed the problem. So first step, you have to replace the s by j omega. So instead of s, you put the j omega for getting the frequency response. You have to replace s divided by j omega. That will be your first step. Then second step, you have to find the corner frequencies. When wherever there will be a 1 plus term, there are a corner frequency. Here there are 3 1 plus terms, so there are 3 corner frequencies: 1 by 2, then 1 by 4, then 1 by 2 by 5. So in this, which one is smallest? 0.25 is the smallest. So that will be taken as a first corner frequency. So that will be WC corner frequency 1. So next highest will be the 0.5. So that will be corner frequency 2. The third one will be the 4. So omega C1, C2 and C3. So that will be in increasing order. Corner frequency should be in increasing order. So next step, you have to note that if you are finding slope, if omega, the slope value is 20, for omega square it will be 40, omega cube it will be 60, in case of omega 4 it will be 80, multiplication of 20s. If omega in numerator, then slope is positive. If the omega is denominator, the slope is negative. So first you have to tabulate the terms in the increasing order of the corner frequency. So first, without corner frequency, the first term will be the 5 divided by j omega. So next corner frequency. So here the omega will be in denominator. So I will put minus. Here it will be omega. So that's why I put minus 20. So there is no change in slope. So next corner frequency is the first corner frequency 0.25, which is belongs to 1 divided by 1 plus 4 j omega. So you have to tabulate in the order of omega C1, C2 and C3. So the 0.25 belongs to the term 1 divided by 1 plus 4 j omega. Again the omega in denominator. So we have the slope in minus 20. Now we have to find the change in slope. So we are putting minus 20 plus this minus 20, which is equal to minus 40. That will be our first change in slope. Similarly, you have to find the next term. So here the omega in numerator, right? Numerator means plus. So again it will give plus 20. Now we have to find the change in slope. Plus 20, here minus 40, which is give minus 20. So next, again the omega in denominator, so it will the change slope will be in minus 20. Now we have to find the change in slope. Minus 20 plus minus 20, which is equal to minus 40. Now we have to find the table. Next you have to find the magnitude value for different corner frequency. You have to choose the lower corner frequency and higher corner frequency. Lower corner frequency omega L should be less than omega C1. Similarly, the omega H should be greater than omega C3. So I will take it as omega L as 0.1, omega H as 10. So you have to find the corner frequencies. After that, you have to find the A value. So for corner frequency 1, formula will be the A equal to gain equal magnitude equal to 20 log term 1. So as per the table, what is the term 1? 5 divided by j omega. So 20 log 5 divided by j omega. Here omega equal to 0.1. So now 5 divided by zero point 0.1. So for zero point 0.1, the magnitude value will be the 34. So similarly, you have to find the next corner frequency omega 0.2, that is also the 20 log term 1. So term 1 again 5 divided by j omega. So 5 divided by, here the omega equal to 0.25. So now the value will be 26 dB. So for similarly, the second formula will be the change. Note that for third corner frequency, the formula will be changed. First change in slope into log of current omega divided by previous corner frequency divided by previous A value. So first change in slope in the table is the minus 40 into log of current omega value is the 0.5, previous omega value will be the 0.25. Next you have to add the previous A value as 26, then you have to find the A value. Similarly, you have to find the omega C3, the same formula will be used. The second change in slope, you have to include the second change in slope, you have to find the A value. For omega h, you have to find the third change in slope which is given in the table. Now we have to find the A. So now we find the magnitude plot. We have to find the different magnitude for different corner frequencies. Next we have to plot the magnitude plot. In magnitude plot, the phase will be, for omega it will be 90, omega square it will be 180, omega cube will be the 270. In case of 1 plus term, it given as tan inverse of omega. Similar to the magnitude, if omega in numerator, it will be plus symbol. If omega in denominator, it will be in minus symbol. Now you have to find the phase plot. For that, phi equal to first term 5 divided by j omega. Here the j omega in denominators I will put minus 90 because it will be only omega term. The next will be the 1 plus 2 j omega. It in numerator, so I will put a plus symbol, tan inverse of 2 omega. So next term will be the 1 divided by 1 plus 4 j omega. That will be denominator, so I will put minus tan inverse of 4 omega. Similarly, the 0.25 omega is also in denominator, so I will put minus tan inverse of 0.25 omega. So these are the formula for the phase plot. Now for different corner frequency, you have to find the omega, different omega, you have to find the phase angle by using the calculator. So you get the different phase angle. So now we find the magnitude for different frequencies. Similarly, we find the phases for the different frequencies. Now we have to sketch the Bode plot. So in similar graph sheet, the x-axis in the frequency and y-axis in the amplitude. So first you have to take in terms of 10. So 0.1, then 1, 10, 100 and 1000. So they are all in corner frequencies. So first half will be the magnitude A, 60, 40, 20, 0, minus 20, minus 40 and minus 6. Then you have to, for 0.1, what is the value we get? That 26. So next you have to find 36. Next value we have to find the omega value will be the 20. So you similarly mark all the omega values in the graph with the corresponding corner frequencies with the magnitude. Then you have to join the points to get the magnitude plot. Similarly, the second of the graph will be used for phase plot. So you take it as a phase plot in negative. So minus 100, minus 10, minus 120, minus 130, 140 and 160. So similarly, for different corner frequency, you mark the phases as per the table in the phase plot. So you have to mark the different for different corner frequency. You have to mark the corresponding phase angle. Then you have to connect all the values to get the phase plot. So this is the final Bode plot for the given open loop transformation. Thank you.